Welcome everyone to the OutSystems user group. Wonderful to have you all here. Tonight we've got some fantastic speakers on the Enhancing OutSystems Application Performance Strategies for Optimisation. And that's not a mouthful at all, it's okay. It will get even harder to pronounce some of these topics as we go through, but our experts are here to make it nice and easy to understand all these strategies for you. So tonight we've got Leonardo Fernandez, Stuart Harris and Manish Gupta joining us, who will be presenting our topics. So before we get started, just a reminder that we have the order of events, what we're expecting to happen tonight. We have the welcome and introduction, then we're going to be presenting the dev tips, and then we'll be finishing off with a bit of a Kahoot, which is an opportunity to test your knowledge. The answers are in the presentations tonight, so the closer you pay attention, the easier it is going to be to get those answers correct. So that'll happen. We'll give you the links for that at the when we get to that stage. And just a little bit about rules of engagement. If you haven't used Google Meet before, you can ask questions at any stage by typing them in the chat window. You'll see the little chat icon in the lower right-hand corner. So feel free to do that now. You can type in where you're joining us from and say hello. And then also during presentations, we just ask that you mute your microphone so that we can hear the presenters nice and clearly. We'd also love to see your reactions. So feel free to turn on your camera. They don't get recorded unless you're speaking, but we'd love to see your reactions to that. You can see the camera icon just to the right of the microphone icon, not down the bottom. And you can also turn on the reactions bar, which Stuart's already been playing with, by pressing the smiley face, and that pops up that little chat icon there. And so you can give your reactions throughout the evening. And finally, toilets are conveniently located over there. I hope you know where they are, because I don't. Rightio. So we're going to move on to the first topic here. So that's brought to you by Leonardo Fernandez. He's an OutSystems MVP and #1 in the OutSystems community worldwide, having worked with OutSystems since 2006. Leonardo is the head of delivery at Phoenix DX, and tonight Leonardo will focus on application performance. So over to you, Leonardo.
Hi, everyone. I'm going to talk about application performance, but I guess to have an introduction on the topic, I wanted to talk about this triad or triangle of trade-offs when it comes to performance. There's always a trade-off between performance, velocity, and adaptability. So what is each of these three dimensions that you can focus on a project? So performance, I think it's pretty clear. If you focus on performance, you're focused on having your application perform faster and finish tasks faster for your users. If we focus on velocity, we're focusing on delivering features faster. So speed of development, which OutSystems is all about, has a, focus is very strong in velocity in terms of OutSystems ecosystem. Adaptability means doing things for the future or for rapidly reacting to change. And we can't have the three of them. All right, we have to choose, I guess, a strongest of these vectors, and then maybe some combination of the other two in lower rate. So typically a project starts off with great velocity, great focus on velocity to get to a first version. And then at that time is when the focus changes to performance. It's about the time when we release the first version that we really care about performance. And then we might take a bit more care in terms of adaptability after we have the first version released. We need to think about the future and next releases. So there's always these trade-offs. And so we need to be careful when we are investing in performance. We need to understand if we're making a good investment or not. And how can we know if we're making a good investment? It's pretty simple. We have to measure. And what I mean by measuring is we have to measure before we made the optimization. Of course, measure after to understand that we really optimized. And you might be surprised how many times I've spent, hours and days optimizing something only to end up with something that was lower. So if I haven't done the measurement, I was actually making the application worse. That happens more often than you might think. But we should also measure the parts of the application that are slowest in a real world scenario, preferably in a production scenario. So we can understand that we are optimizing the parts that are more valuable to our users. It's also very frequent that we start optimizing a feature that we ourselves as developers feel that, there's performance to be gained in that part of the software, but that part of the software is not used so much by users. So it's not a valuable part of the software. And I also want to put this quote over here, that programmers have spent too much time worrying about efficiency in the wrong places, exactly what I was mentioning. And at the wrong times, starting up a project is probably not the best time to be optimizing your project even before it's released, right? That's called premature optimization, and at least according to Donald Knuth, that is the root of all evil. So pretty strong opinion that Donald has, but I guess I share the same opinion as his. With that out of the way, we're gonna look into, I try to classify with my experience the problems of performance and how can we categorize them. And I think this covers pretty much a great part of the performance problems that I found in my career. So I'll have a brief look into these performance problems. So as you've seen in the previous slide, most of them are bottlenecks. That means that the application is trying to perform some action or some task, but there's a slow part of that process, and that's what we call the bottleneck. If we're looking for bottlenecks in the database, or if we're suspecting there is a bottleneck in the database, my advice is that we start by looking into general log in Service Center. So this log hosts many kinds of logs in there, but we should filter by the word slow SQL. There's a filter, you can probably see it's pretty tiny in the screen, but you can see that I've added a filter by slow SQL, clicked filter, and then I highlighted in yellow a few of these queries are turning out to be 20 seconds, 3 seconds, 6 seconds. So you're gonna hopefully be spotting some patterns of which queries are slow at this time or in this interval that you are looking at. So I think that's a good start, at least for you to identify which queries you need to optimize. An example of why these queries might be taking too long is you might be missing a filter. So for example, these filter that I've done, sorry, I think I misspoke. You might be missing an index, not a filter. This query that I just, this filter that I just added in this screen, this slow SQL, that will only be efficient if there is a filter, if there is an index on the database on that particular column. So pretty much every filter, at least in large enough tables, should be mapped to an index on the database for the filter to be efficient. So a solution for this is probably fine-tune the index, create new indexes, or it could end up rewriting the query. Sometimes the query might just be inefficient, and just with a few hours, you can rewrite it and be much more efficient. Now, second bottleneck is external systems. So if you're integrating with an external system, you should be suspecting that it could underperform in some circumstances. And the first place for you to go is to integrations log. The integrations log will have pretty much every integration that you are doing in OutSystems. REST, SOAP, SAP would be listed in here. And this has a column dedicated to performance, which is the duration column. Again, I've highlighted some very high numbers of duration, 11 seconds, 13 seconds. So this would hopefully allow you to determine some patterns of which APIs are taking long time and on which circumstance. Okay, I think it's an invaluable tool, this integrations log. By the way, all of these logs can be exported to Excel and analyzed further. Depending on the way you've integrated with the external system, you might look into extensions log instead, not integrations log, but you should probably know whether you've used a REST API or an extension to integrate with the external system. And the analysis works just the same. It has a duration column, and you should try to spot high values of duration. Example would be maybe an old system that is underperforming, or maybe some network path is not ideal. Maybe you have two different services on different geolocations. A solution for this is, it really depends on the use case. Cache can probably help you. And replica, which is kind of same thing as a cache, right? So I would try to use that to, if I can't change the external system and optimize the external system, really don't have any ways to improve the performance other than caching or replicating the information. An example of how to analyze this in Excel, which I do a lot. Actually, it's the first thing I do when I want to look at performance problems, is I download the integrations log, or any of these logs for that matter. And then I plot time against the x-axis. So horizontally, there's time. And on vertical, there's duration. So you can see most APIs or most requests are pretty fast in under 2 seconds. But then there's some times where there's some peaks, or some APIs take more than 8 seconds or 10 seconds in this case. So this allows me to see, how terrible the system is, and allows me to focus on some region. Maybe I want to look at all of the requests that are taking more than 10 seconds. And when I solve that, then I look from 10 to 5 seconds, and etc. The next bottleneck, which can happen in 2 different cases, is a bottleneck in the client network. So in this case, it is, you don't have any slow queries, you don't have any slow integrations, slow APIs, but your page is still taking a long time to load. And it could be just a very simple problem of you're downloading too much information, and that just takes time to download. So in this case, I've highlighted one scenario where the page load was downloading 2 megabytes worth of data. Most of it images, so it was all being downloaded at once, and the browser can only render the screen after that download completes. So it was taking almost 20 seconds to download in this case. So to look for these problems, if there's no evidence on the server side that your application is slow, no slow queries, no slow APIs, try to open DevTools in the browser and see if you have one of these problems happening. Solution for this would be to somehow try to reduce the payload size, maybe identify data that is not needed during the page load, and prevent that data from being downloaded, or maybe split that into multiple requests. Maybe the images can be downloaded in subsequent requests, so you have a quick page load and then the images start loading. Which leads to a different variation of this problem. And I see it very frequently, but I don't see many people complaining a lot about it. So I wanted to raise awareness of this. This happens mostly when you have a list screen and then each element of the screen is either a block or an image. So it fetches new information from the server. So if you have, for example, 50 elements in a list, and each element is triggering another fetch from the server, you're going to have lots of requests queued up by the browser. And what happens is exactly this, that the first requests might finish quickly, but the last request will need to wait for all of the 50 requests to finish. So you do have a quick page load, but then the information loads very slowly after that. So in this case, you can also use DevTools to identify this. This is image, or this capture that I've made illustrates that. The request's still happening even after page load. A solution for this would be to cache these subsequent requests, which is maybe difficult to do in some cases, or use HTTP2. HTTP2 optimizes this and allows you to have pretty much unlimited requests happening in parallel. Next, this is just a zoomed in version of that page load, and you can see the images popping up slowly all across the screen. Those are the requests that were queued up by the browser. That can happen with images, but also with blocks, web blocks. If you include a web block in each element of the list, and that block has an aggregate or some data fetch from the server. And the very last, and just to bridge to the next presentation, if you don't have slow queries, if you don't have any evidence of any of the previous problems, then you might just have a very fast query that is just executed many, many times. And these problems are maybe the trickiest ones to spot or to fix. But then we'll have another presentation, I believe, from Stuart that's going to talk about that. So I'll leave it for him. He's going to talk about this in more detail. And that's it.
Excellent. Thank you, Leonardo. It was fantastic. As always, if you've got any questions, please just drop them into the chat, and we'll hopefully have some time at the end of the evening to get some answers for you. So the chat icon in the bottom right. So now we'll move on to the next slide. Click next. Stuart Harris is a tech lead at Kyandra and an OutSystems champion. He's been coding in OutSystems for the last 6 years, building solutions in the insurance, real estate, employment, government, and health sectors. He enjoys stretching OutSystems and dad jokes to its limits. Stuart will present a deep dive into optimization of parent-child data. So over to you, Stuart.
Thank you. That was a beautiful extension of the intro. Thanks, Leonardo. That was an awesome explanation, sort of covering the breadth of the sort of problems. And so what I'm going to do is just deep dive into one specific problem, as Leonardo mentioned. So again, thank you. So what are we going to talk about? Well, first we'll just talk about what is parent-child data, what I mean when I say that, and hence the dad jokes. The challenge with parent-child data, then what you get in the default table page with OutSystems when it gets generated. Then we'll have a look at a few different examples, and I'll show you them in Server Studio of loading parent and child data together in different ways that might perform differently. Now, before we sort of get into this, remember what Leonardo said is don't optimize prematurely. So do this when you've identified a problem. Obviously don't design your things badly in the first place. So have some architectural thought about it, but don't jump in to do the most complicated thing that I'm going to show you here if you don't need it. Okay, so right, so parent-child data. It's basically a data model where you have a parent entity that has multiple associated child entities. And often you're wanting to, well, in this example, you're wanting to list the parent entities with showing information about the child entities as well. So examples are projects and tasks, and that's what I'm going to be using as the example today. Employees and skills. So you might want to list all the employees with all of their skills and or no skills if it's me. And then users and roles. So a user might have multiple roles. Okay. So what is the challenge? So let's think about, we have a list of projects and they each have 0 or more tasks. So we need to go and have a look at each of the tasks for each project that we're listing and get data from them. So that gives us a time complexity problem. And I've got displaying here using big O notation. So, so if we have something that's order 1, that means it's constant. So constant time. Using a dictionary lookup is constant time, no matter how many elements you have, because it's 2 operations, hash and then look up the hash. Actually, sometimes there's an extra step where there's a hash clash, but let's just pretend it's always constant. Then there's log n, which is kind of ideal. Normally you can't do better than log n. And log n is that yellow line there. So as the number of records increases, the increase in time sort of reduces. So it's only increasing a little bit as you add more records. Then you've got ON, which is, it increases with the number of records linearly, which we don't really want that. We want to try to avoid that. And ON squared is what we get if we went through every single project and then went and queried for every single task. Right, so that's the challenge. What are we going to do? Well, glad you asked. The default table list. Right, so when you just generate, well, when you let OutSystems generate for you a table list, it's already fast. It's doing some awesome stuff for you. First of all, it's using paging, which for those who don't know what that is, I'm guessing no one, but displays a page of records with navigation between pages. So instead of displaying 1,000,000 records, it just displays 50. And then if you want to see the next 50, you go next. You know how that works. We can specify the sorting for a column, or we can specify that a column can be sorted, or you can get your words right, Stu, that you can sort the table by a particular column. And we use start index and max records to do the paging, where the paging is going to start and how many records we're going to display. But the default table list does not display project data. Didn't start my timer. Good on you, Stu. So how are we going to display that? How are we going to display that child data? Well, what we're going to do is display the count of tasks for each project and the names of the tasks for each project. I've created a data set we can use. And so what we're going to do is we're going to, oh, what happened?
Oh, you're going to take over?
Yes.
Yes.
I think I am. Right, present my entire screen. So where are we? Should have had that one ready. Okay. I'm presenting to everyone, Crash. Can everyone see demo 1? It works?
Yes.
Excellent, thanks. Right, so we're going to query the projects. Then for each project, so that's up here. Then we'll get the total records using the count of that aggregate. We're going to then query for the task count and the tasks. We could do that in one, but it's just an example. And so this is slow, but it works. We won't be able to sort by the task count or the name though. And there's a bit of a problem with the start index that I'll show you. Okay, so let's go over to Service Studio. First of all, this is the default project list. We've got our aggregate that gets projects, and we don't have the number of tasks, and we don't have the tasks. Let's have a look at this aggregate. We can see we've got start index and max records. So that's doing our paging for us. Awesome. Right, and if we go to the browser, we can see that, go to the browser, Stu. So that's our project list. Okay, so that works. Now let's look at our list the slow way. So now we've retrieved the number of tasks and the task names. Right, so how do we do that? Projects number 1. So what I've done here is I've created a data action, and we've got get projects. Now let's have a look at this get projects. We've got max records. Where's our start index? It's not here. So you don't get the start index in aggregate in a data action. What a pain. So you kind of have to go back to, it's like aggregates were in traditional web, where you actually have to retrieve the first page and every subsequent page up until the page you're looking at. It's not great, but that's what we have to do. So we do that, but then the secret sauce is on our for loop where we're actually going and getting our task count, we put our start index in there. So even though we are retrieving more pages than we really need, if we go past the first page, we're only going to do these queries for the results that we want. And then we're going to add them to a result structure. And then we're going to use that to do our display our table. And the sort attribute we can use because it matches the attribute name in the query over here. Okay, hope everyone's following that. So that's the kind of easy, slow way. Actually, it wasn't too fast. I've got 1 million project records here. Did I say it wasn't that fast? It wasn't that slow. So first lesson in premature optimization, that's actually working all right with one user on a website. However, normally we don't have one user on a website. So I'd be pretty sure that this wouldn't really perform very well if we threw a performance test at it, but I'd want to find out. Okay. So we've got it working. Now, the first sort of optimization really is we're going to use group by. So with group by, we can use a aggregate function to count the number of tasks. So we'll query the projects, use group by to get the number of tasks. We can't get the task names though with a group by. Sort will work. There's a weird issue with sorting, but I'll show you. Okay, so right, so there we go. That doesn't really seem much different, does it? And I'll let you know, it's not really much different when there's just one user using the system. Maybe the bad one isn't so bad. But look, we can sort by the number of tasks. Notice that's going a little bit slower now. But that's a bonus. We haven't got the task names though. So how do we do our group by? Let's have a look. So we've joined project and project task. We've used with or without because maybe the project doesn't have any tasks. If we used only with, we would not include projects that don't have tasks. We don't want that. And so basically what I've done here is just gone group by, group by, group by, group by on all the attributes that we want to display. And then on our, doesn't really matter which record we do it on, but I've selected our project task ID and said count. So what that gives us is a count of all the project tasks in the project. Now I'll leave it up for you as a task yourself if you wanted to have different counts for the statuses. So how many are open, how many are closed. You can still do it with a group by, but you actually have to use a sum instead of a count and have some new attributes. But that's an exercise for you to, that's your homework. Okay, so now what's the weird issue with sorting? Well, the weird issue is that we have this table sort here. That kind of works fine. When you convert your basic project list to a group by, sorry, it's going all over the place. The table sort stops working. It all looks like everything should look, but it just stops working. So all you need to do, and like I thought it just didn't work when I first started working with OutSystems. What you need to do is delete it and then re-add it, and then it'll work. So remember that one. It'll save you 3 days, guarantee you. Okay, now third demo. We're going to use a dictionary to retrieve the task count and task names. So let's have a look at how that works. There it is. And so how do we do that crazy magic? Well, we just retrieved the projects. Remember, we've got the start index plus max records again. We have that same problem. And we're gathering a list of the IDs of each project. We just put them into a list. And then we use the build safe integer int clause integer list from the sanitization module. We pass that in, and so now we run another query to get the tasks. And I know you're saying, hey Stu, but you're running another query. I thought we didn't want to do that. Well, I'll get rid of that. We're only running one other query instead of a query for every single record. So that's why it's better. We're grabbing account, and we're using this magic here to produce a comma separated value for the task names. So we use stuff, well, actually, first of all, we use this for XML path on the end of this query where it has add a comma and a space and the task label. So what that does here is that will produce a string with comma, task name, comma, task name, comma, task name, but it's got a comma and a space at the front. So what we use stuff for is to say, hey, at position number 1, so at the start, remove 2 characters, replace it with nothing. And so that removes those from the front, and then we have a comma separated list. That's kind of a standard sneaky way to get a CSV in SQL. There you go. And there's our in clause. Now, people will say to you, an in clause, it performs really badly. Well, does perform really badly, but up to a couple of hundred records, it's actually fine on SQL Server. And over about 1,000, then it starts to fail depending on the complexity of your query. So that's okay. We're only doing 50 records. That's completely fine for in. Now we do the same thing. So for count and name, we create a dictionary. We go through all of these. We actually set them with a key being the project ID. Then as we go through the project list, we go, does that dictionary contain a key? Yes. We'll then get it. We'll get the value and then put it in the number of tasks. And then when we append the record, put the number of tasks in our structure. So that's 100 miles an hour. But this lookup here is super fast. So we're doing one query, quickly going over 50 records, one other query, quickly just going through those 50 records, putting them in a dictionary, going through 50 records again, and producing our structure. So instead of 50 times 50 times 2, it's about 5 queries and really fast. Okay, so last. Now with SQL, we went through using stuff. So that's how we create the task names. We know how to do a group by for the count. Now, paging in SQL. How do we do that? Well, we pass in the start index and max records. For paging, we need to know the count of all of the records, not just the 50 that we're retrieving. So we need to do 2 queries really. So, but we don't want to hit the database twice. So we could duplicate the query and hit the database twice, but we can also use a common table expression, or CTE, to define the query and then use it twice. And we do it like this. We go with, give it a name, temp result, and that's our query there. Select whatever we want to do. Then we have another CTE, temp count, and that uses the first CTE, and that's the number of records. And then we put them together. We go select star from temp count. So the total records is at the start of our structure, and then the rest of our results. And we've retrieved the total number of records and the result in one go. Then we need to just retrieve the 50 that we want. So we use our sort by to order it. Then we use offset and fetch next to retrieve the offset just to start from our starting position, and fetch next just to receive 50 records or 50 rows only. Okay, let's have a quick look because we're just about out of time. Here we go. And so first of all, this is it. We just retrieve it all there, return our records, our total records, and we're done. So all the magic is happening in here. We have our temp result. We have our query that has a count. It's got the group bys down there. We're using our magic stuff action in there. This string ag thing, you can use that instead of stuff, but in only later versions. And you don't have a later version on your personal environment, I don't think, unless it's a really recent one. We have our other CTE where we select the temp count, and then we select them both. And so this structure here has the total records as the first attribute. So it pulls that as the first one. All of these attributes next, and offset and fetch next. Okay. So where are we? That's how we retrieve our records in one hit to the database, but we still get our sorting and we get our paging. Thank you.
Brilliant. Thank you, Stuart. So now we're going to hand over to Manish. Manish Gupta is an 11 times OutSystems certified professional and an OutSystems champion. He works as a solution architect at Vision Forge, an OutSystems partner in India. Manish will give us his best practices for performance and optimization. So I'll just have to add you to that, but over to you, Manish.
Yeah, thank you, Michael. Just add me as a co-present, so I'll able to handle the presentation. Thank you very much, Leonardo and Churat, for sharing all the insights about how the performance works. And now I'll be sharing most of the part which already Leonardo and Churat has shared with you, but I'll be simplifying some of the rules of the performance. So how is the Josh for everyone? Want to see some comments in the chat? How is the Josh? Great, great. So again, welcome to this presentation on the performance and the best practices for basically this data modeling design. In the session, we'll discussing about the logics, we'll discuss about the queries, how those should be built. Next, we'll talk about the top 10 rules of performance optimizations, and then we will be talking about some of the performance optimization warnings which True Change share with us, and how we can solve those queries. So this is how we'll proceed. So let's kickstart the things with exploring the critical concepts of indexing your entities in the data model. And indexing is like building a roadmap of your database to find information very quickly. When you create an index for attributes that are frequently to use in the queries, you are essentially enabling the database to retrieve the data faster. However, it's important that we create the indexing for the attributes which we have to query fast, but we should also know, or we should also note that it slightly slow down the insert and update operations when we are creating the indexes. So this is the slightly a note that we have to take care about. And to strike the right balance, we should identify the right attributes that appear in the query condition and join the expressions in the slower queries. So these attributes are prime candidates for indexing. So you can see on the slides as well, we have the solution and as well as the importance of this, why this indexing of our entities are important. Similarly, we have this again as a best practice of isolating the large text and the binary data, which also aspects of performance optimizations. So basically the text attribute with having the 2000 characters, having more than 2000 characters, can pose a challenge for your performance. So to mitigate this, we should consider to minimize the text attribute lengths. Sometimes when we are talking about the CK editor's text or the large amount of text, we require that, but we should minimize that wherever is required. basically whenever we are dealing with the binary data, then it should be separated into the entities, and this warning also come in the true change when you are working. So it's wise always to store these attributes in the separate entities, and this practice can prevent the slowdown that often accompanies updating entities and the large text and the binary data attributes, because binary data is not something which you either call every time, or whenever you have to do any update operations you update those as well. So if we are keeping it separate from the main entities, then it will affect the performance while updating the data, while retrieving the data. So this is also an important aspect of isolating the large text and the binary data in the data model. Then we are delivering into the scenario that many of us encounter dealing with the large Excel files. When managing these files, basically it's crucial to implement strategies that prevent performance bottlenecks. These performance bottlenecks we saw in the previous presentations as well. And the one approach is to record the data in an entity, and we should use a timer to process it in the background. So if you are dealing with a variable number of line of upload, ensure your application can handle Excel's maximum record. So the Excel's maximum record are 65,536 for most of the cases, or it even may go to the 1 million in case of Excel 2007 record. So it's important to note that Excel loading time can increase as the data table grows, and a table should insert. So basically, the insert action of the table may become slower over the time. So to keep your application responsive, consider to employ a temporary table to the store that will store the binary data from the Excel and process it timely asynchronously using the timer. So this approach basically helps to maintain the efficient processing and prevent timeouts. This is one of the point, because whenever we are working on any large enterprise applications, the export and the import feature is one of the feature which we used to use in the applications, and this is how we can manage the large Excel files and their performance. Moving forward, we have to use the delete rules constraints in the entity, and we should look into this. Those connect when we are connecting, or we are creating any relationship with one entity to another entities, then at the right place only we should use the delete rules constant, because when we are not using any of the entities data, and if the associated data is not useful for us, then we should use to delete it. So if you all remember, we have three primary options for the referential integrity, which is a protect, delete, and ignore. So the protect rules demand all the records from the child entities to be deleted before deleting the parent entity record. When it offers the data integrity, it can be a performance intensive. And the delete rules essentially leaves control to the database and potentially resulting the inefficiencies. However, the most best option is the ignore rule. Basically, the most intriguing option I will say is the ignore rule. This rule basically leads you towards the inconsistency of your application, because you are ignoring the dependent data from the child entities and the parent entities whenever you are deleting something. So yet from a for performance standpoint, I'll say that it's remarkably efficient that you are deleting the data, but it's also important to know as a part of data modeling or a data scientist that our our data management should be up to date. It should be crucial. It is crucial that we keep it accurate for our application and for our demand. So we should remember to choose a delete rule wherever it is possible, for deleting those entities which are not required when, if any, primary data has been deleted from our application. Similarly, in data model itself, we have an option for archive old data in the separate entities. For example, whenever you are fetching any data and we have the lots of data available over there, then we can keep those into the separate entities, and old data because whenever we are calling into a table, the paginations are there. We talked about that. So the updated data, whichever we are calling on the screens, can be on the top of it, and and we can archive all data into the separate entities, which basically will help us to retrieve the data frequently. It will help, and for all the historical data, for all the data which is been old now as 3 months 4 months old, then we can use a timer for this kind of migration. So we'll use the old tables over there. So to implement this effectively, we should consider and automating data cleaning concept that can be done through the timer. It can be manual as well, but I'll suggest to have a timer over it, so the process will be done automatically. So this is another concepts of having the data model with a separate entity. So these were some of the ideas that we look into how we can handle the data modeling with the best practices as per se of the performance. Looking forward, we have the logics. So let's start by discussing the practice of utilizing service center reports to enhance the performance of your application. We had this discussion with Leo as well, and this approach holds immense significance as it allows you to identify and address potential performance bottlenecks. And we had the previous slides over it. So whenever we leverage the service center reports, we basically get the ability to closely analyze and fine tune the application's performance. This becomes efficient, especially crucial when we encounter any sluggishness into the application access, or on the web screens or VAP screens or the web services or timers. Then it becomes important to look into how much time it is taking in executions, which Leonardo basically told us about how much milliseconds it is taking and what are the ways to optimize it. Additionally, the slow database queries or integration is also reported into the service center, which we can look into, and we can empower ourselves basically, I'll say proactively, by identify these kind of bottlenecks into the service center, and can make our logics more efficient and can troubleshoot the execution time over it. So this is how in the logic we can use the service center reports for the performance per se. Again, we should always avoid long running timers and the batch jobs. So basically, it's important to note that managing timers and the batch jobs requires the strategic approach. So the timers that run for extended periods can lead to an unforeseen issues. To mitigate this, it's advisable to limit the timer to run maximum of 20 minutes, and then we should have a backup timer, or it should be rescheduled for this. And achieving this requires an explicit timeout within the time logic, which we always used to read about this into our best practices of development with a timer, where we have the backup timer once this data is not done. And also we used to keep the record of where the last timer was run, which record was handled lastly, and how we can handle it to the next time. Importance of this is because the excessive timer duration risk to the endless reprocessing, and it slow downs the server, not only with the timers but with the processes as well. When we use the BPTs or the BPMs, we have the best practices of killing out the ideal processes, where we use the wait, we use the timeout, and we use the terminations of processes wherever required. So this is how the best performance for this long running timers is something that we can use. And then we should also think about simplifying the screen preparations. And in the traditional itself and the reactives, we have the screen lifecycle sections that we should think about. So the loading of speed for screen significantly impacts the user experience, because whatever data is getting load, Turet has shown us the demo for this, the live demo, and the Leonardo also shown us the console, that when we are loading the screens, basically the images are getting load, and the life cycle is still going when the page is load. So that's crucial to simplify the screen preparation action. So some of the points that we can have is, first, we should avoid the complex preparation, as overly interact ones can impede screen responsiveness, as overly we should look into one of the common scenario, watch out the pre-processing as a query result, that what are the results that we can have the pre-processing, what are the results we should do on the on demand, and what are some of the information which is not required on the screens but still we are loading, and we can stop that and we can only call them on the demand simply by just passing the identifier of the record. We have multiple logics for this to look into. We can use for each loop, we can use different kind of if loop, and depending on the requirement we can use our loop into calling the data whenever it is required. So the optimal rendering time will be affected through it, and our screens will be simply to load and will create a better user experience while doing this. Moving forward, we should also think about using the site properties, because it is important to approach again strategically about the site properties, because site property should be treated as a constant rather than a variables. So if your application is required frequent changes of the site properties, then we should consider an alternative approach. Instead of changing site properties on screens or the session, we should think about using the database table to store the site properties properly wherever we required it. And to manage these changes, we should incorporate back office functionalities for streamline management, where user can log in at the back office and can change the site properties efficiently. Whenever the site property is altered, it triggers an immediate database change. So this operation takes time, and it requires application to acknowledge the new value promptly. To achieve this, we have a tenant invalid cache operation available that is issued and repeated, and repeatedly we should making the changes can lead to the increased application database overhead, because the cache is getting created every time. So this database overhead get created. So when dealing with the site properties, we should strategically plan it. Either it should be changed from services to service center. If it is not, if it is changing frequently, we should use the databases of it, or we should also we should also prepare a back office part of changing the site properties if it is needed. So this should be done before starting the development itself. This planning should be done as part of architecture design. Again, when we discussed about the site properties, the session variables also comes that we should use wisely, because the session variables helps to optimize the performance, and we should limit the session information. We should avoid the large record and the list in the session variables. We should prefer to store filters in the database with the user ID, because it's basically help to have our application or the request optimized. Otherwise, having the large session variables slow down the request, and it increase the contentions. So this is how it works for the session variables. Moving forward, we have in the logic itself, we should avoid using the aggregates efficiently to avoid unnecessary overhead. We should not use the isolated aggregates. The aggregates basically are the powerful tools we all knows for summarizing and manipulating the data. However, it's essential to use them wisely to optimize your application performance. And a key point to note that creating standalone actions solely for executing aggregates can lead to inefficiencies. So whenever an action is called and its output is an entity or a record list, then the entire entity or entities with record list are fetched from the database. So basically it is fetching all the data from there. So basically this operations occurs even if the action does not utilize all the fields, because you can see that in the aggregates we have multiple attributes, but not every attribute is being used into the screen. So we should make necessary decisions and wise decisions over it, that what field should be called and what data should be visible on the screen, so the optimized data can be called over the screens whenever the data performance is been done.
5-minute warning, Manish.
Yes.
Thanks.
So we have we should also avoid the if branches in the preparation. Lastly, we should address this practice as well that can have a significant impact on the view state of a page and rendering, that avoiding the use of queries inside if branches during preparation. So when it comes to refresh screens, the conditional query is executed within if branches can introduce an unnecessary query data into the view state itself. So to counter this, adopting a strategic approach is essential, and one effect variables and assigning queries result to these variables. So you all might have used the local variables already into your projects, but the importance of those are this, and this practice basically help to execute the queries within if branches. And why it is important? Because the execution of conditional query inside an if branches leads to inclusion of query in the view state. As a result of view state size get increase, and potentially it hamper the performance of your application. The scenario primarily apply to the submit action for the traditional. Basically in the reactive we don't have such option, but for the traditional, when we are having the submit button, we have the ajax actions available for the and the dest, and when we call any other destination, this practice doesn't hold true there. So by taking this approach, you are ensuring optimal view state management and enhancing your application's responsiveness. This is how the logic practice works over there. When we are discussing about our database practice, the logic practice, we also have our queries that we use into our application. So the queries practice also works, and in the realm of multi-tier application, the database layer often become a pivotal area for the performance considerations, and particularly in the context of queries, I'll say. So these practices become especially relevant when dealing with external or linked server. So by consciously, whenever we are working, the set of practices should be outlined that we should use for mitigating any performance bottleneck in our application. So when it comes to the linked server and the cross servers join can remarkably inefficiently work together, they should avoid it at all cost. So the solution here is straightforward, that we should steer clear of cross server joins, and by dealing with the linked servers, we should the cross servers joins always compel that entire link servers table to be loaded into the database server before join is executed. So everything which we have on the link server should be over here at our platform, and any temporary database or any of the temporary entity structure, and then all the logics, all the joins or something which we are talking about, the data subsets or the child data, should be executed at our environment. So this is how in the queries we can handle the linked servers. Then we should always minimize the fast fill from database. So we have the max record property in aggregate, which we should use always to minimize the field which we are fetching from the database. And the solution is basically we can use a structure instead of the whole entity records, because as I mentioned earlier as well, this is not always required that you are using all the attributes of a entity. So the structure can be prepared for that, and a max record is also there for fetching the records. I'll say the records, the minimum records or the required records for this. And so when we are using the structure, you will narrow down the amount of data which is which is flowing from the system, and it will reduce retrieval from the database and enhance the performance for you for the better data load. This is how it works. As I mentioned in earlier slides about the max record, so when we are controlling the number of fields to be extracted from the database, we should also talk about extracting number of records. So max record should be set properly into the aggregates with accordance to the volume of data that is needed to be displayed on the screen. And the solution for this is it optimize the queries execution time by limiting the fetch record to match the display requirements, and it helps to maintain consistency between max record and display data, enhance screens the loading by retrieving only the necessary records. This is how this also helps us to optimize the performance. Then For the bulk operations, we all know it's a best practice as well. And for the queries, it comes into the performance best practices of queries, that whenever we are having the bulk operation, instead of using for each loop, instead of having the large server actions, we should use the SQL queries. And leveraging on SQL queries for bulk operations help to increase the performance for the bulk tasks, and it helps to reduce the data inefficiency or reducing the communication overhead for processing over the speed. Coming to the next, again we discussed about this, that we should avoid using the isolated aggregates. And isolated aggregates uh, basically have more memory uses in the database, and whenever we are calling the isolated aggregates, or we required a particular view state of an data on our application, then we required multiple aggregates to be there to be called for the data display, which creates an unnecessary overhead. So we should avoid it, though these of the practices are coming from the Leo and what Leo presented and what Theoret has presented. But this is a simplified rules which gives you an insight about how we are we are creating a performance best with the queries logic and data model. Again, we used to use these indexes and the multiple iterations for whenever we are working for the queries. So we should always limit the iterations over the queries, and it results once. And we should reference from using direct indexes like this uh, squares and passing the iterations over it. It helps to prevent unnecessary data duplicates in the memory, because as I mentioned, whenever we are having this data call, it is creating a caches over there, and the unnecessary data will be duplicate in the memory when we are calling, we are iterating the data again and again with the different indexers. So how we can solve it? We should avoid multiple iterations over the queries, and we should use the direct indexers for it to solve it. So iterating multiple times over a query result duplicate data in memory, and increasing memory consumptions hindrance the performance for any application that we are building. Coming over the next point, we have the minimizing the number of executed queries is a vital strategy to reduce communication overhead and enhance overall performance. So the solution here resolves around grouping aggregates or SQL queries for fewer executions. And why it is so important? Because each query executes incur a round trip communication cost. Because so by reducing the number of queries, we can significantly decrease the communication overhead and improve the system efficiency. So it's worth that while minimizing the executed queries counts offer significantly performance gains. So whenever we are minimizing the execution queries, our performance are getting improved. So it's a diagonally proposed to each other. And when we strike a balance between performance optimizations and code readability, then also it helps that we are not having these duplicacy executions between the systems. And we should always utilize the service center to analyze and get the insight about how much time our query is taking, about how many queries is being executed for it, that help us as a report to solve the performance issue.
Manish, we might
After
have to get you to wrap up shortly.
Yeah, sure. Definitely, we can wrap up shortly. We have this performance top 10 rules, where this performance we should always index our queries. We should set up database maintenance plan. We should have our service center reports that we can use. We should join over link server. We should don't join over link server. These are the some top 10 rules which we have already discussed in the database logic and query part. So these are some of the rules which you can copy over. And moving to the last, we have some of the suggestion warnings, and we should fetch suggestion warnings which true change basically to tell you while you are developing an application. So these are some of the decoding of how you can work over it. So fetching the data on the splash screens, then this message comes in the true change. and which causes fetching data from server in a splash screen slow due to the remote request and the increasing user wait time. So our recommendation for this is to fetch data only when needed, place server aggregate or data action on the default screen, and simply splash screen for the faster navigation, allowing concurrent data fetching. The second warning which comes is the client action calls several server action, and we should group them into a single server action for the better performance. So the recommendation is we should group a server action into single one and use it to reduce the requests. The third one is the server action generates several server requests. Execute for each inside the server action for better performance. This is a message which comes in the true actions, and because basically it causes a iterating server action in a client action which leads to the multiple requests. So for the better performance, we should have to perform for each in a server action that call it into a client action, and we should reduce the request to one. Then we have the optimize on initialize action. This this message basically call here we have to access. Basically, this is for the mobile local storage or server delaying the screen block render. So use aggregate or data action instead. So the recommended action is we should move all the local storage or the server logic to the screen aggregate or data action, and it speeds rendering the concurrent data fetching. Then we have for the JavaScript library, which contains the JavaScript library for better performance. And so basically, whenever the JavaScript is required, so we should use from the external libraries. We should not use it from the external libraries, and we should make it in the resources itself. So this is how we works for the image optimization. If we are using any image of a heavy size, it a message warnings comes, and the suggestion or recommendation is to reduce the image size in bytes, adjust dimension, and follow the image optimization best practices. So this is how these works regarding the small rules of having the application optimizations. Thank you.
Excellent. Thank you, Manish. That was fantastic. Don't worry, everyone. If you didn't pick up all the information that was shown there, we will make those slides available for download, and we'll send out an email hopefully tomorrow, so you can download all the slides and get all the detail that has been presented. Just got a quick call out for volunteers. There's a Australian-based charity called Impact for Women that provides support services for women and children fleeing domestic violence. OutSystems have provided an ODC environment to build custom applications to help them deliver on their mission. So if you'd like to volunteer in any capacity, please contact me. My email address is there for further details. So just quickly, every Mother's Day and Christmas, Impact for Women deliver almost 2,500 bags of love each time to women and children in crisis accommodation to provide some hope. So if you would like to help, we're trying to build some applications for them that will help them expand their capacity to deliver and provide support to women and children in need. So again, my email address is there. We'd love to get more volunteers. We've already got a very large team, but there's always more room for more. Thank you everyone for coming along this evening. I hope you had a great time. Learned a lot from these fabulous OutSystems knowledge base wizards, Leonardo, Stuart, and Manish. So thank you very much, everyone.